Okay, let's start. I want to review what I've covered in previous session quickly. So for those of you who were absent, or those of you who are still absent in a class but can hear me in hopefully the recording today, so you can access what we have covered. So we talked about the normalization, right? So we started with introduction to relational databases. We said what can be actually called as a relation. We talked about the entities, relationships, attributes, different types. So by now, I expect you to know different types of attributes and relationships. And we learned how to draw ER model, use entity relationship diagrams to model our database. And then we also learned how to convert that that ER model into a relational schema, right? And we also introduced different types of keys like primary key, foreign key, and so on. And this week we started on normalization, which is a very important concept in relational databases. So we said that basically normalization is just organizing your data and your tables in a way that you want to avoid redundancy and inconsistency, right? So for instance, we said instead of, I started with this example that what if you store everything, all the information about different entities? Like for example, in the student registration example that we used in this class. So I said, okay, what if we just store student information, course information, instructor, department, and everything together in one single table? So what was the problem with storing everything in one table instead of separating them in different tables? Yeah.
You delete one employee or student?
No, it doesn't matter. Let's focus on the student example that we used for this class. Let's say I have a student ID here, a student name, course ID, or really like marker, course name, and then instructor, let's say ID, name, and so on, and also department information. So what was the problem with this design?
So if a student leaves, or if you want to delete the student part, we lose all the information about the department.
Yeah, exactly. So we talked about different types of anomalies that can arise, like insertion anomaly, deletion or delete anomalies, and also update anomalies. And so we said that, for example, if we want to insert a new department, let's say university have just built a new department, but we don't have any students or courses or instructors there yet. We still want to keep the department information, but we don't have other information, so we cannot enter the data. And then what if, for example, we have a student who wants to change his supervisor, right? Let's say Mona wants to change her supervisor. And then we also have stored instructor information in this table, right? So when we want to update our table and we want to update Mona's instructor from, for example, Dr. Detler to Dr. Yufei, okay? So if she wants to change, then you have to change the instructor name wherever that you see it here, right? Or for example, let's say you also have the instructor office here, and the instructor wants to change the office. So again, you have to update the office number wherever in your database that you see that office. So let's see it in the example here. So we said, let's say we have this database, and let's say, for example, Dr. Brown wants to change his office from 102 to 105, And then the problem is that you don't have to only change here, but you also have to change multiple rows here. So in this example, the table is very small, so you only have to update 2 rows. But in a real case, you may end up like updating thousands of rows. And not only is not efficient updating multiple rows instead of only one, but it may also cause inconsistencies because like sometimes you enter data manually in databases or update like a field manually, then if there is like any also human error there, it causes inconsistencies. What if you forget to, for example, update that value in one row, and so you end up with different values of the same field. And we also had delete anomalies. So delete anomalies is when you want to delete, for example, a specific value of a column. Like for example, you want to delete a specific student because she maybe dropped from the program, and so you end up deleting all other information that were stored in the same row with that student, right? And maybe you don't want to lose those information. So maybe, for example, Mona is the only student of, for example, Dr. Detler, right? So if you delete Mona, you're also deleting information about Dr. Detler. Maybe Dr. Detler later gets a new student, but you lost information about that advisor. So here are the anomalies that we already discussed: insertion, update, and delete anomalies. So here are the examples that I mentioned. And so how to prevent these anomalies? We use normalization. How does normalization help us doing that? How does normalization help us prevent these anomalies? Like anyone else? So how do you get rid of this problem? Yes?
So it breaks up the table where we see all the anomalies into smaller tables in such a way that if we were to edit or add info, it doesn't disrupt.
Yeah. This is what we mentioned about normalization, right? We said it's all about breaking down like these large tables into smaller, a few like smaller but more structured, and I would say more focused tables, right? So I would say each table preferably focus on a specific entity, and that is why your ER model is very important, because then you will have less, you will have to put less effort on the normalization part. So now let's say you came up with a really awful ER model, and then you have like this big table here with all the information, but we still can do the normalization to make things work. So here, for instance, it just separated information about the course, as you see. So you have like course information in a separate table, instructor information in another table. It should also have a student table, right? So maybe it's just due to the lack of space, but you also have a student table somewhere. So in this case, if you wanted, like, for example, remove a student, or if a student dropped from the program, you only have to update the student table, right? So you don't change anything anywhere else. And the same for other things, like for delete, insert, and update, for all the examples. The same is, for example, for the instructor, course information, and so on. So I added a new slide. You remember, you could hardly see my example. This was a non-normalized table here. Do you remember this example? It was really hard for you to see, so now you can easily zoom to see the table actually values. So here, what are the problems in this table? Multiple, like non-really related values of different entities all together in one single table, right? So in this table, we have a first name and last name of a student. We have his or her email. We have advisor information department. So this is the exact same example I had with only like more values here. So we covered like 3 cases, and this was just an example covering all cases. So the first one was if, for example, we said, what if Matthew want to change his advisor to Tang? Then we need to update advisor email as well, right? Or like the worst, if he wants to change Baker to Valdez, then you not only have to change advisor email, but also advisor department and admin, because these also have been changed, right? And in case of, for example, delete anomaly, if, for example, you delete a student, then you will lose the department information and also the advisor information, right? Some of your faces really seems confused. Is it like because, is it that you didn't get this? So is it clear for everyone? Okay. And this last one was for just the insertion, right? So you want to like insert a new department, let's say biology department, but you don't have a student or advisor information yet. And so these are the 3 problems that we discussed. I really like this slide. This is more clear now. And this is the version after we do the normalization. So after we break that big table into like separate smaller tables, each one focusing on like one entity, one for instructor, one for the student, and one for department, for example. And then we talked about functional dependencies. This is also very important because if you don't understand functional dependencies, then you cannot understand normalization at all. So we said we have 3 types of normal form, first, second, third. We actually have more. We have 4 NF and so on. But the focus of this course is only on the up to 3 NF. So we had 3 types of dependencies, right? So we have a full key dependency. And then we had partial dependency. And then we had transitive dependency. Now, in order to understand these dependencies, you also have to understand different types of primary keys, right? So, for instance, I said if in a table you have a composite primary key, right? That is a primary key that is composed of more than one column. Like, for example, 2 columns or 3 columns or more can uniquely identify each row in your table. In that case, you have a composite primary key. What was the example for that? What's an example of a table, for example, with composite primary key? I'm really happy you are in this class. So, yep. Enrollment, yes. So enrollment, because in the enrollment table, you have the student ID and course ID, right? And then we said, for example, in such table, because each student, let's say a student ID 1, Mona, is taking, for example, this course, EECS 4412, right? And then she's also getting like ECS 3421, and the same course is taken by more students, right? 2 and 3 also taking this course. So in this table, so in the enrollment table, because each student can be enrolled in more than one course, right? And also each course can have more than one students that are enrolled in that course. So we said that this couldn't uniquely identify your primary key because your student ID is duplicated, right? Course ID alone couldn't be primary key too because it was also not unique, so it also repeated. So, but the combination, because each enrollment is specific to one course and one student, right? Then together they can uniquely identify each row. Now my assumption is that you can only enroll in each course once. If you are enrolling in each course more than once, then you may even need more columns to as a composite primary key. Or you may actually have a date. If you have a date in the same, for example, table, then you don't have even that issue, right? Because, for example, if you, let's say this is a semester, then even if I'm enrolled in the same course, like ECS 4412, right? Let's say I'm enrolled in the same course, same student, right? But then you have the semester, right? Maybe I enrolled in fall and then also in winter. So for those of you that who may ask, for example, if a student enrolled twice, then you can get 3 of them as your composite primary key. Now, so this was a composite primary key, just a review of what was that. And so what was partial dependency? We said if in a table, if there is a column or columns that depend on just part of your composite primary key, okay? So for instance, let's say in the enrollment table, you have course name, right? And just to keep things simple, forget about semester now. And now, let's say I have course name, this is data mining. And this is database. Now, with the dependency, I said, when I say, for example, course name depends on course ID, that means course ID can uniquely identify course name or course title. That is, for each course ID, you have a unique course name, right? So you cannot have, for example, if you change your course ID to something else, then you have a different course. So that is dependency. So the course name depends on course ID. Now, we said we have a full key dependency if a column depends on the whole primary key, whether it is a single primary key or the whole part of the composite primary key. And it is a partial dependency if there is a column, for example, course name, that depends only on part of your primary key. So here, course name only depends on course ID, right? Does course name depends on a student ID? No, because same student ID can have different courses, right? So they are not dependent with each other. And so we say there is a partial dependency in the enrollment table, and this is your primary key. So this is a composite primary key. So you have composite primary key, a student ID, and course ID. Now, you have a partial dependency here if a column in your relation depends on only a part of your primary key. Now, I'm making your life easier. Depend on part of your composite primary key, okay? Because if there is no composite primary key, can we have a partial dependency? Let's say I have a single primary key. How could you have a partial dependency in a table with single primary key? For example, a student table, you have a student number as your primary key, and then a student name, and so on. So I have here a student table, a student ID, then I have a student name, email, right? And so on. So this is your primary key, right? A student number or a student ID is primary key in the student table. Could I have any partial dependency in this table? No. Because by definition, partial dependency means a column in a relation depends on part of your primary key. Now, a single primary key doesn't have any parts. It's just one part. So if a table has a single primary key, there is no way you can have a partial dependency. You don't even have to look for that. Now, note. So can I say if we have a composite primary key in a table, so if a table has a composite primary key, we will have a partial dependency? Is this correct? How many of you say it is correct? Not correct, right? So you can have a composite primary key, but only like full dependency. Like for example here, if you're storing only course ID, student ID, and grade, right? In this case, you have like maybe 90% here, 70% here, and so on. So in this case, grade depends on both course ID and a student ID, right? So grade doesn't only depend on a student ID. Grade is not only dependent on the student ID, right? It depends on both of them because each grade is unique for a combination of a student and course. For like a student, for example, Mona, can get 90% on one course, but like 80% in another course. So in that case, that is an example of a table with composite primary key, which doesn't have any partial dependency. But I would say if you want to check for the dependencies, first check for the primary keys. If it is a single primary key, you don't even look for that. If it is a composite primary key, then you have to check, okay? And if a table has composite primary key, so this is composite, then yes or no, you have to check. Now, in this case, if that column depends on only part of your primary key, then it is like in previous example, if in your enrollment table you have course name or a student name, so a student name depends on only a student ID, which is part of your primary key. Course name depends on only course ID, which is part of the primary key, so that those are partial dependencies. And if that was the case, so if you have an enrollment table with a student ID, a student name, course ID, course name, and grade, so you have combinations of full dependency and also partial dependencies. Full key dependency doesn't matter, we keep it there, okay? It doesn't cause any issue. But partial dependency means that your table is not in second normal form and you want to like normalize it. And then I will let you know how you can do that. Now, full key dependency, if a column depends on like completely on, let's say, or exclusively depends on primary key, all part of primary key. Now, so far, these two, like for the full key dependency and partial dependency, you are checking your primary key. So everything is about the primary key. Now, for the transitive dependency is about non-key column. And by non-key column, one of you, I think I asked me if it could be like also foreign key, and that is yes, okay? So it could also be foreign key. But by key here, in this context, I mean just the primary key, okay? So it could also be between like foreign keys. So transitive dependency, if a non-key column depends on another non-key column. Or non-primary key column. You can read it that way. Now, if, for example, you have a table of employees, right, with employee ID, name, and you also have the department right there. So in that table with employee ID, employee name, maybe some other information, then you have department ID, department name, and so on. Here, department name, first of all, let's say in this table, this is the employee table, and you have, for example, either another primary key or employee as a primary key. This is just for the sake of an example. So here, department ID is a foreign key, right? Because it was primary key in another table. But this is a non-primary key or non-key column here. This is 2, and we say that department name depends on department ID, right? Because each department ID is unique for each department name. And so this is a transitive dependency because the dependency is between 2 non-key columns. Usually, like you have when you have like address information, right? For example, city usually determine like your address, determine, for example, your zip code. In that case, for example, you may have transitive dependencies. Or for example, between let's say instructor name and location, okay? If it is not inside an instructor table, like the example we had before, the table that was non-relational table that we had here, right? Now, here, we can say there is a transitive dependency between instructor, office, and instructor, right? Because these are like 2 non-key columns depending on each other. Now back to this example. Now, so are these clear? Now, based on these dependencies now, you can identify what are the normal forms. So which normal form do we have? Or we covered here in this class? First, second, and third normal form, right? So we have 1NF, 2NF, and 3NF. So for the first normal form, this is all about atomic values and no repeated groups. If it is like 2NF, it means it is already 1NF and no partial dependency. And we know what is partial dependency. And then for 3NF, it is already 2NF. That means they are like values are all atomic. You don't have no like repeated groups. You have no partial dependency, right? Now, up to here, it is 2NF if there is no partial dependency too. But for 3NF, it should also have no transitive dependency. Okay. So let's see this with like examples that we cover. So first, let's see the dependencies here. So we said, for example, a student name depends on a student ID, or you identify it like when you want to show dependencies in your, for example, assignment, you show it this way. A student ID defines a student name. Okay, this means a student name depends on a student ID. So here you can see that, for example, course title depends on course ID, right? A student name depends on a student ID. And grade depends on both a student ID and course ID, right? So where is my mouse? Here. So grade depends on both course ID here and the student ID here. So can a student name, does a student name depends on course title? No. So these ones with the question mark here is no, actually. So for example, course ID doesn't depend on a student ID, or grade doesn't only depend on a student ID, or is not only depend on the course ID. So we said a relation is in a particular normal form if it satisfies a certain specified set of constraints, which we explained, for example, for a table. And it's good to remember like overall this picture, because then you know, for example, for a table to be in 2NF, it should already be in 1NF. And for a table to be in 3NF, should be already in 1NF and 2NF, and so on. So we say a table is in 1NF if each record is unique and no column like have multiple values. So this problem can arise like in two different ways. Either you have multiple, like you have different things stored in a cell, like two different things. I mean, you have a column with address. So you have, for example, a column, for example, customer name and then address, right? Now, here you store my email address and my home address, okay? Something here. So you're storing two different things in a single column. If that is the case, that like is not atomic values, in this case, how do you resolve it? If there are two different things in a like single column, you have to add another column, right? One to store email address, one to store the home address. So you may have now customer name, email, and home address or whatever. So if the problem is about storing two different things in a single column, then you have to add a new column. But maybe you're just putting multiple values of the same thing into one column. Like for example, you have email here, right? But maybe I have two email addresses. Maybe I have Gmail, Yahoo, and so on. And you're storing my Gmail, Yahoo, everything here. This is not a relation. This is not in a first normal form, okay? So we cannot call a table where you are like storing multiple values in a column, in a cell, and say, okay, this is like normal. This is not in the first normal form. And in this case, how do you resolve it? How do you resolve if I have like multiple emails here? Separate rule, right? And yeah.
So, when you say you put it in the same cell, you mean it's like it's the same thing? It's the same
Like this, for example. Like this.
Oh, okay.
Yeah. So for instance, for this student, the first row, so student ID something, name is Williams. So for this student, because he took like two courses, now you're storing two courses in the same cell, right? Now, what if you want to access, for example, a specific course here that Williams took? Like, what if you want to, like, for example, delete his database course? How do you do that? Or if you want to, like, update that? Because how do you do that? Later in SQL, you see. So you are updating it by this field or this column, right? You say, for example, update this table, right? Set, for example, this column to some values, right? Where you have some conditions. And now, which ones do you want to get? Like this is now, like for in relational databases, like for example, SQL, it doesn't read it like two different things. Now it is like a one thing, right? And then you have to do like kind of like a string match manipulation to do it, which is complex. So you don't want to store multiple values in the same cell. And this is what I mean here. So no repeated groups. This is repeated groups. These are repeated groups here. And so we either want to like add columns if they are representing different things, different attributes, or we want to like add some rows, which is the case here. Because, for example, here they don't represent different things. They are all courses. They are all course titles. So it's enough that you just add rows here. Now you will come up with this table, right? So you have a student ID, course title. Now everything is in one row. We don't have any, actually, we don't have duplicated groups of data. Not duplicated, repeated groups of data. And we can say that data are like atomic here. So what is the normal form of this table? The one on the bottom right. What's the normal form of the table on the bottom right? Is it in 1NF? Yes, okay, that's good. So I want you to understand it by like just 1NF so far. So this is first normal form because we do not have multiple values stored in a cell. Now, is it in a second normal form? This one? So first, for second normal form, you have to check for partial dependencies, right? For partial dependencies, you have to check the primary key, right? What is your primary key here? So your primary key, is it student ID? Yeah, both. A student ID cannot uniquely identify each rows here because this is in like enrollment table kind of things. And course ID also is not unique. So a combination of course ID and a student ID are forming your composite primary key here. So now it's getting interesting. We get like composite primary key. Now we may have a partial dependency, right? Do we have partial dependency? Yes. Between which columns? Yeah. Yeah, for example, course title depends on only course ID. So there is a partial dependency here. And yeah, if we had, for example, a student name also, that was another partial dependency. So let's go to the next one. So here, so this we already explained. Now, this is just explaining what we have covered in those tables, which I already explained. So we were removing repeated groups of data that we had originally here, right, by adding more rows. And then because we were adding rows, the student ID were repeated, right? Because, for example, what happens if you have one student here, let's say student 1 is taking, for example, yeah, 2 courses, right? So at first, it stored like back to your question. So it was like this. So for this student, it stored both courses like this. You cannot do that. So what did it do? It separated, so added more rows. But now we have another issue, right? So we came into like first normal form, but now we have the partial dependency issue. So as I mentioned, we say a table is in second normal form if it is already in 1NF, that is no multiple values in a cell, and no partial dependency. And partial dependency is when you have, it may happen when you have a composite primary key, but if you have a single key, you can forget about it. Now let's see here. So you have, let's say, your composite, these like green ones are your composite primary key. So you have like A and B, these columns are your composite primary key. And if column D, depends on only one part of this, that is B, you can think of it as, for example, course ID and D as a course name, okay? So the way that you normalize your table, how do you normalize your table? You just want to break it into more smaller tables. How do you break it? How do you decide which columns you put in each table? Based on these dependencies. The ones that depend on each other, you put them in a separate table. So you have a dependency between D and B, so put them together in just one table, and then put the rest here. So in case of, for example, this table, here is your primary key, right? Composite primary key. Now, I said course title depends on only course ID, right? And instructor name and location kind of depend on the course ID if you assume that each course is taught by only one instructor, right? Now assume that this is the case. I just want to make it simpler for you. And grade depends on both of these. So everything that depends together goes into a separate table. Grade depends on both of these, so it goes into the table with this, right? So we also have to create another table with the remaining parts, the red ones, right? These are also dependent on each other. Now, we can further normalize this red table here, right? Because we still have dependencies. We have dependency between instructor location and instructor name. What do we call this? Which type of dependencies between instructor location and name? Partial. So in that case means that which one of them is part of your composite primary key? So if you have a partial dependency, it means your primary key was a composite primary key. Okay, so course ID. Is it a composite primary key?
Not now.
No, not now. Okay, we're talking about this table. So in this table,
Instructor name.
okay, what is the dependency between instructor name and location? If it is partial, it means, right? It means.
Sorry, I thought you were still in the previous.
No.
This one is the third.
Yeah, the red table here. What is the type of dependency here? Yeah, transitive, because these are like non-key columns here. When I say instructor name determines its instructor location, right? Instructor name. So if instructor name changes, its location also changes. So instructor location depends on instructor name, but both of these columns are non-key columns, right? They are not primary key. So in this case, this is a transitive. So when you define your dependencies, you see, like for example, if you say, okay, course title depends on course ID, right? So do we have a key column here between like these dependencies, course ID and course title? Yes, we have a primary key course ID. Is it a single primary key or composite? Single primary key. Can we have partial dependency here? No. So that is the way that you do it for all the tables, right? So you ask yourself, you find the dependencies, and then you check for the primary keys. Are those columns key columns or non-key columns? If they are non-key, they are transitive dependency. If that is a key, you have to define the type of the key. If the key is a single, you cannot have, it is not possible, and I emphasize it is not possible to have a partial dependency, okay? But if it is a composite primary key, then you have to check. Like for example here, we have a composite primary key, but maybe we have a column that depends on all parts of primary key, like grade that depends on both the student ID and course ID. And in this case, it is a full dependency, right? Even though we had a composite primary key. Although we have also partial dependencies in this table, the partial dependencies are, for example, between course title and course ID, right? Because course title depends on only course ID, which is depending on only part of your primary key, not the full part of primary key. So is this clear? Now, and you know how we broke this bigger table into two tables. We put whatever depends on each other in a separate table. Like these green ones depend on each other, so go into one table, and these ones go to in another table. Then again, within this table, we find more dependencies between, for example, instructor name and location. So let's put them also in another table. If you want to like further, because we're still like in these slides, I was expecting that the next slide showing me the table, another table, which it didn't, sorry, because we're still in the second normal form. So it's just explaining what I already mentioned. Your primary key is a student ID, course ID. And these are the dependencies. Grade, for example, depends on both part of primary keys. So this is a full key dependency. And also course title depend on course ID. But because it only depends on course ID, which is just part of your primary key, this is a partial dependency. And then it explains how we remove partial dependencies to create a table. One of them is 3NF, one of them is 2NF. This one is 3NF. Why? The green table here is in third normal form. Let's start with the 1NF. So this table is in 1NF. Why? All atomic values. Is it in 2NF? Yes. Why? No partial dependency, even though we have composite primary key, but we have only grade here that depends on both parts, so it's a full key dependency. And because we don't have partial dependency, it is already in 2NF. Now, why is it in 3NF? No transitive, right? Now, this is just explanation of third normal form, which I already mentioned. This is just another example. So let's see also this example together. So we have this Mountain View Community Hospital here, and this is similar to order processing. So your patient is like, for example, you can like assume this is like your customer table. Procedure is like, for example, product, and treatment is like, for example, your order line. And so this is kind of like a report, not a table. So we have everything together here, like the date, patient code, patient name, procedure, and charge. Now, if you want to like put everything that you have in your report into a table, you will come up with something like this. Now, assume that I want to like define a primary key with this table. What would be the primary key here? Can I have doctor name as primary key? It's not unique. How about specialty? Not unique. Date? No. Patient name? No. So none of them. How about combination of two or more? So each doctor, right? A combination of doctor and patient, if we say, can a combination of doctor name and patient be enough for primary key here? No, because, for example, one patient can have different procedures, right, with the same doctor on the same day. So it also depends on the date, and it may also depend on the procedure. Like, so there should be another circle here, because on the same day, same doctor can have like multiple procedures, like X-ray or like just normal examination on the same patient. So this table in 1NF. This is not, right? We have like multiple values stored in this cell. Is it in 2NF? No. And what is the primary key here? We should define a composite primary key, right? And composite primary key with doctor name, date, patient code, and possibly maybe also procedure, because also one doctor may have like multiple procedures on the same patient on the same day. And so we'll come up with 4 columns. We only have 6 columns, and 4 of them are our primary key. What do you suggest? What can we do here? Do you remember when we were talking about different types of primary key? And so I mentioned about one particular type of primary key that could help you here. Now assume you're like working in the project. This is your report, and this is a table. How do you want to like define primary key here? Do you keep the composite primary key that I suggested? Combination of like those 4 columns? Yeah.
This might not be what you're looking for, but if you had a unique doctor ID and you could just combine the doctor ID with date, that would just be 2 parts, because if you have a truly unique doctor ID for one specific doctor, you can only do one thing at a time. So if you have just doctor ID and date.
Yeah, the same doctor ID then, right? Let's say doctor ID 1 can
But I guess if date also had like a specific time, then
Does it?
well, it doesn't here, so I
So-
guess that doesn't work then.
Yeah. So you don't have that information in this table. So in this case, you can add surrogate key, right? What was surrogate key? Surrogate key was a key like generated by the machine, right? Automatically generated. Like in many cases, you may actually use it in real case because it's just integer and automatically added. Look, so you're not working with like multiple text columns. Even if these were like IDs, I still told you like one unique ID. Let's say Dr. ID 1 can work on patient ID 10, right? At the same day, right? Having like multiple, for example, procedures. And the same doctor ID can also see other patients, right? So doctor ID alone couldn't be the primary key. Also, if you add a ID for the patient, which we already have, patient code, again, alone, they don't work. So you will come up with the 4 columns that I mentioned. And so, because it's not efficient, you're like, these primary keys, when we are talking about indexes in the relational databases, you will learn like what is the goal of like indexing in the tables. And primary key, like by default, is used as an index for like all the tables. What does that mean? For now, you just have to know, let's just know that it means faster querying your data, okay? And if we want to like have 4 columns, it doesn't work well, right? And especially because for primary key, we want something that don't change, don't be updated regularly. That is also one thing to keep in mind, okay? And so we add a surrogate key here as a primary key. So let's say a visit ID, something like a visit ID or any ID name that you want to put on it. And so now this is unique. So here you have a table with the visit ID, doctor name, specialty, date, patient code, and patient name. Sorry. So what normal form is this table? The table on the left. First, start from the first normal form. For first normal form, it should be atomic values, that is no multiple values stored in a cell. And just to clarify, this is one word, internal medicine, okay? And this is also one name. This is first name, last name, but this is just one name. So this is one NF, right? We don't have repeated groups of data, right? So this is one name, just first name, last name. Now this is in one NF. Is it in 2 NF? Do we have partial dependency here? If you claim it is in 2 NF, means we do not have partial dependency, right? So what is the primary key here? Yeah. If we add visit ID, then we don't have any partial dependency here, right? And then it will be in 2 NF. Then your dependencies will be the 3 just violating the 3 NF because they will become transitive dependency because they are like just non-key columns. Now, if we didn't add this, now you can see how many dependencies you have here then. Because this will become your primary keys then. Patient code, doctor name, specialty will become your primary key. And if you want to like keep these primary keys without adding a surrogate key, then you will not even be in second normal form, right? And how about this one? So in this table so far, we just separated the procedure. So we have procedure and the charge. So which normal form is this table? Apparently this is first normal form, right? Because it doesn't have any, all values are atomic. We don't have any multiple values stored in a single cell. Is it 2 NF? What is the partial dependency here? Partial dependency means you have a composite primary key. So here in this table, we have composite primary key, right? Because visit ID is not unique. in the table on the right, the smaller table on the right. Visit ID is not unique. Procedure is not unique, right? A combination of visit ID and procedure are unique because in each visit I mentioned, in each visit you may have multiple procedures like X-ray, whatever. So a combination is a composite primary key. We may have partial dependency, and we actually have, because charge, so the amount that the doctor charges depends on the procedure that it does, right? If it's X-ray, it might maybe, for example, more expensive than just normal examination. So this is a composite primary key. We have partial dependencies, so it is not in 2NF. We need to further normalize it into 2NF, right? Now keep that in mind, and also keep this table in mind. So you wanted also to further normalize this table where we have doctors, patient, all information here. So now you have doctor information in a separate table, you have patient information in another table, and visit information in one more table. So how did you do, how did we know that we have to like change the, add a table like this? Like how did you know that, for example, doctor name and specialty goes into one, patient code and name into one? Yeah, so we looked at the dependencies here, right? So I told you when you want to normalize this table, check the dependencies. For instance, patient code name depends, specialty depends on the doctor name, right? Because, for example, each doctor have a specific specialty. So a specialty of the doctor depends on the doctor. Now, either doctor ID or name, here we had doctor name, so it depends on doctor name. Now we have this table, and then we have a patient table here, and then we have this table. So they are all in third normal form because they are all in 1NF, right? They have atomic values. They are in 2NF because they do not have any partial dependencies. We don't have composite primary key here, no composite primary key here, and no composite primary key here. If there is no composite primary key, means we cannot have partial dependency. We are already in 2NF. Now we check for 3NF, right? Is there any transitive dependency? No. Because there is no transitive dependency, we are in 3NF. Now look at this one. So this was based on like this table. So I just want to make it clear. We had two tables here, right? That we normalized this one step by step. So you can do it all in once, but I just wanted to make it like more clear. That is why I do it step by step. So step one, you came up with like, let's say these two tables. And then based on this dependency of like this left table, the table on the left, you created three other tables. Okay, one for doctor, one for patient, one for visit. Before this normalization, all of this information were just in one table here on the left. Now, what about the table on the right? We said that this is also not in second normal form, right? We have to normalize this. How can we normalize this table? Like this. So if you see, we have visitor ID, procedure, and charge. So what we added here is actually we just added a procedure code, right? So that we can have a composite primary key of visitor ID and procedure code. And then here each like composite primary key, visit ID, and procedure code can uniquely identify each rows. What would be your dependencies? Do we have partial dependency here? Yeah, we have a procedure name that depends on the procedure code, and charge that depends on the procedure code, right? So they are the partial dependency. So you may want to like further normalize that into becoming like this, like all tables in third normal form. Now, in reality, you may not always want all tables in third normal form. Okay, so for your exam, I want you to normalize your tables as much as you can up to 3NF, and but I'm going to explain further on this. For example, for OLAP case, if you are working, for example, more on reporting, let's say, then you may not to further normalize your table, but you may also want to denormalize your tables. I'm going to explain it further. Don't get confused. So these are just a summary of what I have explained. So this is what we have done with the tables, just explained it with the text here. I also provided the very simple ER model for the hospital visit with treatment. Like, for example, each doctor can have no visit or multiple visits, right? And each visit is for only one patient, right? But each patient can actually book no to multiple visits. Now, between visit and procedure, there were many-to-many relationship, right? Through the treatment, because each visit can include multiple procedures like X-ray examination and so on. Each of these procedures, X-ray examination, so on, could be in multiple visits, right? And so this is a associative entity connecting these two together. So this is just very basic, simple ER model for the case that we just had. Converting that into relational schema, we already know how to do that using ERD+. And this is just like SQL you don't need to do that yet. We are starting SQL from next week. So this is just for your information, how you want to create those tables. And just some notes. For example, when you want to create your ER model, each entity must have a key. So don't forget, I see in students' assignments, I often see that they forget to put, when you draw your ER model, you forget to put define your primary key. So you don't have to forget that, because then when you convert your ER model to relational schema, your foreign keys will be lost. How does a relational schema or ERD plus identify foreign keys? Based on the primary keys that you defined in your ER model, in your original ER model. For example, in your ER model, let's say you have an entity employee, you have an employee, another entity for department, right? If you do not identify department ID as the primary key of the department, it will not be foreign key when you convert it to your relational schema, okay? But if you identify it as primary key, then when you convert it to relational schema, it automatically shows the foreign key for you. And that will help you for the next step for your database implementation. When you want to create database queries, you have to define your primary keys and foreign keys here. Now, if you have identified unique identifiers in your entities, in your ER model correctly, your already ERD plus already give you your foreign keys, and then you can write your foreign keys just here. You don't have to guess. And so you may want to stop at just some note on the normalization. You may want to stop at some point when you're normalizing your data. For example, you may stop at 2NF if, for example, performance is your major concern. So because having all these, creating all these tables also is not that efficient. Or for example, as I mentioned, if it is a case of if you need for reporting, also and you don't need frequent updates in your database, which is the case with OLAP. We will learn OLAP later, and we see, for example, in star schema, for example, we denormalize from 3NF to 2NF or even 1NF, because in that case, for example, data warehouses, in that case, you're not interested in frequently updating your data. You just want to get reports, right? And it's faster and more efficient to have them all together. And otherwise, if you are just working on the transactional databases, like operational databases, we want to often have at least 2NF or ideally 3NF. And That's it. And I forgot to check if I've recorded the session. So let's see if